Welcome all, Max of the Accidental Engineer. Today we are joined by Chang She. Chang, do you mind a brief introduction about what it is you do now?
Yeah, absolutely. So I work for Cloudera now, and Cloudera is a big data provider and a machine and analytics platform company. So I work on the product inside Cloudera called Cloudera Navigator. So if you think of big data as your data lake, Cloudera Navigator is your life raft when you're drowning in too much data.
For our audience that doesn't know this about you, I want to make people aware that you've contributed heavily to Pandas, the very popular Python library for conducting data analysis, taking the idea of a data frame as invented, I don't know if that's true, as invented by R, I guess, and porting that to Python, where it is tremendously popular and in use, and you yourself use it on a day-to-day basis.
But yeah, absolutely. So, as you, I'm sure all know, Pandas was created by Wes McKinney. So he and I used to work together at a company called AQR Capital Management. And when we were both kind of junior analysts there, our job consisted of data loading and cleaning data, and data preparation, a lot of data engineering tasks. And the tools at the time were, incredibly inefficient. So Wes went down this path of, okay, let's create tools to make that easy to do. And so, he landed on Python. He landed on, there's this thing called NumPy, and it makes kind of matrix and array manipulations very easy. But then when you actually kind of hit real world data, there's this whole class of problems that NumPy isn't very well suited to solving. And that's where kind of the motivation for Pandas came from. So I was kind of a very early user. This was like before Pandas was even open source. I used, Wes showed me his like first version. I loved it. And so, I was sort of pushing Pandas throughout my group at AQR.
For people who don't know what that use case is, where NumPy isn't adequate, I guess for our audience that doesn't know, Pandas, where NumPy only deals with homogeneous data types, where you have a matrix where your rows and columns and every cell in it is of a single data type. Pandas abstracts and deals with columns only, I guess is one way to paraphrase the benefit of Pandas versus NumPy. Is you can work with heterogeneous data. So you might have a date column or a date index, while you might also have float, integer, string type columns. Am I getting this close to right?
It's one of the main differences for sure. So I think NumPy excels essentially where MATLAB excels, where if you have nice, clean, orderly matrices, then all you needed to do was linear algebra. That was a great tool, and so that's why it became popular. Now, as data science became popular, data science in real world data sets come from a lot of different sources. They're often not sorted or not aligned. They're missing data or have bad data, and there's a lot of, let's say, if you have time series data, then you have to do regularization or downsampling, upsampling, all sorts of these data engineering manipulations that we've built into Pandas to make that easy.
So for our audience that isn't familiar with AQR Capital Management, what were the core problems that you guys were finding the existing tools to be inadequate for solving at AQR? I realize that they're a pretty private company, but perhaps we can dance around the subject and talk a little bit about the types of problems.
Sure. It's AQR it's a large multi-strategy hedge fund / asset management company, and so it has two sort of arms. There's an equity investment arm, and there's kind of a global macro investment arm where it's invests in fixed income assets and other things.
Sure.
The types of problems, this was the time when Pandas was first created. And when I worked there, it was something like, 2007 to 2009, 2010 ish. And at AQR, all that workflow was done in a hodgepodge of Excel, VB script, kind of a little bit of Java and some C++, and all of that used the database as the integration point where they all came together, right? And so it was, not only did you have these data munging problems where none of those languages or ecosystems had a good way to do data cleaning and do vectorized operations on data. And that's just one problem. And then the other problem is, as you go through your data pipeline, you have to jump from language to language to language. And none of that is automated or easy to do. And you always have to go back to the database. And so the database became the bottleneck in a lot of scenarios. And Pandas kind of solved that problem by, one, providing all these functionality to increase productivity. So tasks that took us, a whole day or like several hours to do, was, maybe 5 lines of code now or 10 lines of code. And because Python is so versatile that we could automate, maybe not automate, but we could kind of unify maybe 80% of that data pipeline all into Python so that everything can happen seamlessly in one kind of workload, right? So now you don't have to go from, manage 3 different languages and a database, and you're fighting for resources with other people who are doing the same thing.
When you guys were developing Pandas in this context of finance and working with financial data, it sounds like there might have been an explicit focus on time series data and data indexed on date time. Did you guys at the time, you and Wes, really realize how much more generally applicable Pandas might be for data sets outside of time series, or was that just a surprise? I don't know.
So I think Wes left AQR about a year before I did to go to Duke, and I think when we were working in AQR, there wasn't as much realization of how applicable it was outside of finance, because it is kind of, every industry is a little bit of a bubble in and of itself. But I think Wes left AQR, went to Duke to go to grad school, and so he first made that realization, hey, it's not just useful for finance. And so, I also left finance. He convinced me to leave in like 2012. And so he and I worked on Pandas together for a whole year. This was something like Pandas 0.6 or something like that. And that was the year when we saw, one, a big uptick in Pandas users, and two, that was when Pandas really took off outside of finance. And in the beginning, it was still very heavily financial focused. People were coming in and say, hey, I'm from this hedge fund or that bank, and I need to do this. Can you make a new feature on GitHub? And then, but as time went on, it quickly became clear, oh, hey, like you're not, other data scientists came in and said, hey, I needed this feature, or made bug reports, and more than just not data scientists, but just plain scientists started using this too, and they found it immensely helpful for them as well.
So I gotta credit you guys for making Pandas, because I personally have used it on the job, not so frequently as of late, but to give our audience another concrete example outside of academia and finance where it is applied, or Pandas is used, was at a job I held in the email marketing and advertising space, where we dealt a ton with the choke point of our database and getting data out of the database and being able to be manipulated and played with, like you're describing. We were tracking user engagement type event data, which I guess is also inherently time series, but right. I'm fishing here to try and come up with some other types of data analysis outside of financial data analysis that it's tremendously useful for.
For sure. I'm glad to hear that you found it useful too. Most of the credit belongs to Wes, who came up with the project, and also I think now it's being maintained by Jeff Freeback.
Shout out to Jeff Freeback.
Yeah, for sure. I'm just grateful that I got to contribute to this project and make life easier for data analysts.
So there's a couple of questions I want to run by you about career advice just generally, because I find your career story so far to be really fascinating. Just for our audience that doesn't know it, do you mind sharing about how from college to post-college, we've covered a little bit of ground, but what were you up to? How did you get into programming?
Sure. I got into programming pretty early in high school. I think actually even beyond. I remember my first foray into programming was in 5th grade, and we had these old computers that had, monochrome screen, and the keyboard was part of the monitor and the computer, and we learned BASIC, and we programmed kind of like a question and answer program that told a story. And so I actually wasn't born in the States. I was born in China. I moved to the US when I was 10. So in 5th grade, I was not quite fluent in English yet. And I could read better than I could kind of read or understand in conversation. So programming the computer in BASIC was kind of an escape for me.
Sure.
And so that was my first contact with programming. I really liked it. And I think the interest kind of continued through into high school, where I took a bunch of, like AP computer science classes, and some dabbled in I think back then it was when Java web applets were supposed to be like the future of the internet.
And then what happened, man? I remember that era too.
Yeah. And then, in college, I majored in computer science. But I was a bit of a slacker in that I didn't actually do any real internships in school, and I kind of stumbled on finance my senior year.
Mm. What year was this? Do you mind sharing? Like, what was the job market like then? I realized you went to MIT,
Yeah.
So in contrast to myself and a lot of our audience who didn't go to MIT, maybe the recruiting process is different at MIT versus elsewhere. But was the job market robust? How did you end up finding finance?
Yeah, absolutely. So I went to undergrad from 2001 to 2005 at MIT. The job market was very robust then. This was pre-2008, especially finance during those last few years, like 2005 and 2006 was incredibly hot. So the job market was very good, especially if you were privileged enough to go to a good school. And at MIT, the top firms would come to the career fairs and they would recruit. And the top firms had a pretty rigorous interview process. So it wasn't that you could just show them your degree and get a job.
Sure.
But still, I think compared to most other people that I've talked to, the MIT name carries a lot of weight for employers. So the job market was overall very easy during that time, and I think for top schools like MIT or Harvard down the street, it was even easier, I would say.
So one of the two questions that I mentioned really wanting to ask you was, in conversation outside of this podcast, we've talked about how there's kind of 3 criteria that you have for evaluating a job and whether it's a suit for you. Do you mind sharing for our audience about what those criteria are?
Yeah.
And what your rationale is?
Yeah, absolutely. So I always look at jobs along 3 dimensions, what I call business, the problem, and the people. So one is, at the end of the day, our identities are not attached to our jobs, right? So you have to, at the end of the day, you have to pay bills, you have to make a living. So you have to make sure that the business is viable, and it has to start from the top. You have to believe that the market is in a good place for the industry, right? If the industry is dying, even if this is the best company in that industry, it might not be a good place for you, right? The company has to be in good shape and it has to be headed in the right direction. And the product that you're working on, or the team that you're joining, has to be working on something that is that contributes to the bottom line for that company, right? So all of those things have to happen to say, okay, this is where I can have a stable kind of financial future. Second dimension is the problem. All right, we're not machines, and if you're an engineer or a software engineer, right, even if you have temporary trouble finding a job now, you have to realize if you look at the world overall, or even if you just look at the U.S., we're in a great position in terms of the marketability of our skills. So we get a choice of what problems to work on, and you have to look at this job as, are you interested in working on the types of problems they're giving you? Is it, do you like enterprise versus consumer, or do you like social media applications versus doing kind of like deep data analysis, or is it machine learning? And you have to pick the right kind of technology stack and technology kind of layer of abstraction for you, right? And then the third thing is the people, which is, do you like the people around you? I think that's honestly, I feel like that's probably the one thing that people neglect a lot, is especially as they get more experienced. I feel like, as you get if you're a fresh grad and when you get out of college, this podcast is all the accidental engineer. So this is like they're accidentally making good choices in that how much they like the team, the people that they're working with, and how much they like that daily interaction plays a big part. And I find as people get more experience, for some reason they place less importance on that. And I always have to ask why. If you see that toxic person, or if you see like warning signs about the toxic culture in a team or in a company overall, don't stop yourself. Don't say, oh, I need to make a living, or I don't really care. This is just a 9 to 5 for me. If your daily life is miserable, it doesn't matter whether you're making enough money or you're working on an interesting problem.
Yeah, this almost sounds like a type of hierarchy of needs, or Maslow's hierarchy of needs, where maybe people who wouldn't otherwise be toxic might be toxic because the business is not fundamentally sound.
Exactly.
And so they have stresses about their existential welfare that they might be projecting onto their teammates maybe.
Exactly. And it doesn't even need to be if the company is in dire situation. If you take a look at if you look at Cloudera, for example,
sure.
Cloudera went IPO in the last year, and the stock price has seen a lot of volatility, as all fresh IPO companies do. But that doesn't stop people from, going through an emotional roller coaster as the stock price goes through, a financial roller coaster. For those things, I think for this Cloudera case, it's easy to say, look at the long term. Everything else about the company is good. Just 6 months from now, all this volatility is going to pass, right? But if the company is not in a good place and you don't see a way out, then it's much harder to kind of get out of a toxic mindset.
So before I ask you the second of the two questions, I think it would be a good opportunity to plug that you guys are hiring at Cloudera.
Absolutely.
Especially for Chang's team. If you like person-wise Chang, you should totally apply for a role there. What types of roles are you guys hiring for, or skill sets that you're looking for?
So we're hiring a pretty experienced back-end engineer who's familiar with large-scale, complex, performant enterprise applications. So and it's about our mission is, like I said, being the right life raft for data analysts and data stewards who are working with the data lake.
So for our audience members who might be a few years out from having the skill set that might get that job today at Cloudera, what are some things that you recommend they learn or research to develop their skill sets to be a good candidate?
That's a good question. So I would say, one is along sort of the technical track. So the technical skills you need to succeed in this job are things like, you need to learn how concurrency works. You need to learn how to create abstractions. In that, I think we talked about this before, in that one of the, I wish I had majored in math, like you did, which is, it really helps you think about abstracting from, just from a few concrete examples, and to describe the world using code in as concise and terse terms as possible. and so what I find is, especially with complex enterprise applications, if you're not good at abstracting and creating software abstractions, you have to write a lot of code to do a small amount of things, right? Whereas if you learn that skill, it becomes the opposite, and you get a lot of leverage, and your productivity goes up many times. And you need to know kind of good judgment in terms of trade-offs between, the performance of the code and how maintainable it is, and how easy it is to read and reuse that code. I think some of those things will just come with practice, and that no amount of reading will automatically make you an expert in those things.
So abstractions are a big deal.
Yeah.
Are there specific programming languages or libraries like Pandas that are good entry points or guidance about what's a good level of abstraction? I mean, today, a very contentious topic, which I'd love to get you on the record about, is maybe for an introductory computer science course, what language should they be using to teach the course?
Well, I think you waylaid me with this question. So
sorry, bro.
I love Python, but I guess my first level will always be Scheme, because that's what I learned my introductory computer science, and so I think my first course in computer science at MIT was SICP, Structured Interpretation of Computer Programs, and that was taught in using Scheme. And I loved, learning Scheme. To me, that first course, it just blew my mind. Like every lesson was like, and we wrote streams in Scheme. We learned about recursion. That was the first time I learned about recursion. We wrote a Scheme interpreter in Scheme, and it was just, it was, I would say like the top 3 fun experiences I've had learning computer science.
Mm-hmm. That's awesome. We'll obviously include a link in the show notes to the book, which I think was written by an MIT professor.
Yeah. Two Hal Abelson and Jerry Sussman, I think.
Yeah, so it's freely available online. You can view it in HTML. You don't even need to download a PDF or anything. The second question, coming around back to the second question I really wanted to ask you about was, when it comes to contributing to open source, there's pretty steep learning curve and entry cost. If you really want to know how to effectively contribute to open source, you kind of got to learn version controlling tools like Git and GitHub. Maybe.
That's right.
You got to learn how to communicate efficiently online.
Yes.
One of the topics that is a recurring topic on our podcast is on the subject of making people more employable.
Mm-hmm.
Have you found that your tremendous open source contributions, which I'll call them tremendous, you might be more modest, but have you found that to be a very positive propellant for your career when it comes to skills it developed for you, or by contributing developed skills, or made you better known on the job market?
I would think so, yeah. But more, I would say my contributions were modest, so I would say the benefit for my career has been mostly in terms of kind of network referrals and network effects. And like Wes is the famous, he's the rock star, he's the famous personality, so everyone's heard of him. For me, it's more about the people that I know recognize my skills, and they refer me to interesting opportunities that come up, and I think that's been a tremendous propellant for me for my personal career.
Awesome. Yeah, I mean, I wanted to encourage, speaking directly to our audience, that they should give it a shot if you haven't already contributed to open source. I think people rarely are reminded or told how low the bar can be for contributions, like documentation.
For sure.
This comes up occasionally, but it deserves hammering home that on a project like Pandas, there might be certain aspects of it that are very intimidating to newcomers to open source, like the C code or C++ code or even some of the Python might be more involved. But even as simple as modifying documentation that's not exactly clear to you might help others and will likely get merged if it truly clarifies things.
Yeah, absolutely. So I think I have kind of two comments to make here. One is for kind of the audience and the users of open source software. If you want to participate in the open source community or even just use open source software, you have to learn Git, you have to learn GitHub, you have to learn kind of basics of Python and whatever library you're using, right? But beyond that, don't be intimidated, because even if it's just if you found a problem while using it and you're going on GitHub to create an issue, that alone is already contributing to the project. So don't think of the bar as, oh, I have to like write performance C code in order to be considered a contributor. Even if it's just opening an issue, that's perfect already. And beyond that, in Pandas, we've tried to make it easy and make the contribution ramp a little bit less steep, in that we mark issues as good for beginners, not good for beginners, or difficulty level and priority and things like that. So you can use the tags on GitHub if you're a beginner to kind of just filter out what issues are good for you and just get your feet wet. And we have a lot of tutorials out there for how to contribute to Pandas and not just use Pandas. So, obviously it's not perfect and we can always do better, but at least we've tried to do that and make it easier. And I think that's my second comment, which is to open source maintainers, is if you want a bigger community around your project, you have to make it easier for different levels of people to have different levels of participation.
For sure. An addendum to that I want to also add is, even if you aren't contributing to the Git repo, like submitting pull requests and getting them merged, or like you say, commenting on issues, people can contribute to open source by using the library and talking about it in other fora like Stack Overflow or your personal blog. Those two alone can contribute a lot to the community. I remember early on in Pandas Genesis, there was a lot of conversations that wouldn't happen maybe in GitHub issues, but they would be discussed in Stack Overflow.
Yeah.
And I think it's helpful to remind people that by using open source software and talking about it, even if it's not on GitHub, you're awesome, and keep it up.
Yeah, for sure. Stack Overflow. I remember the year that I worked a lot on Pandas, that every, once a day I would log on to Stack Overflow, look at unanswered questions and try to answer them. And I would go through the top voted issues or top 10 lists and say, okay, are these captured in GitHub issues already? If not, let me create a new issue. And so even just by asking a question, like you said, that's already contributing.
Got it. Are there any things that we haven't covered in the conversation that we should cover that I should ask you about that we've missed?
I can't really think of anything.
Yeah, me neither. I feel like we've covered a ton of ground.
Yeah.
I'm sure we'll have more things to talk about. Perhaps not in this conversation, but hope to have you on again soon.
Yeah, happy to.